Hello, today we're going to present the Start-Stop Buttons practice. First in the theory is the color norms, and we separate in two. For the one line power, the line L is connected with black, neutral with white, and chassis with green or green-yellow cables. The control side of the panel is connected with digital positive, red or brown, and digital negative or ground with black cable. What is the electrical interlock? The electrical interlock is a safety feature used in electrical systems to prevent certain actions or operations from occur under specific conditions. For example, when a door is open, the machine can stop, or some relays connect with sensors that stop the operation from machines. How does the start-stop button work? It has an actuator part. It's a physical part of the button that is pressed to initiate or stop the process. Then we have a normally open circuit. This circuit is a circuit that is not connected in the resting state, and when the button is pressed, they close the circuit and let the electricity flow in the circuit. The normally closed circuit is a circuit that in the resting state is contact is closed and the electricity flows in the circuit, and when it open when you press the button and it act like a normal open circuit.
Single-phase induction motor. Single-phase induction motors are commonly used in a wide range of applications such as fans, pumps, and compressors. These motors are popular because they are relatively simple, reliable, and inexpensive. The working principle of a single-phase induction motor is based on the production of a rotating magnetic field. This is achieved by supplying a single-phase AC voltage to the stator winding, which creates an alternating magnetic field. The stator winding consists of a number of coils distributed uniformly around the stator core. When an AC voltage is applied to the stator winding, the magnetic field created by each coil alternates in directions, resulting in a net rotating magnetic field. The rotor of a single-phase induction motor is not self-starting, and therefore it requires some mechanism to start it. This mechanism will be explained in the next slide. First, we need to start the torque. The capacitor provides a phase shift between the main and auxiliary windings, which creates the rotating magnetic field and provides the necessary starting torque to the motor. Efficiency. The centrifugal switch disconnects the auxiliary winding to the capacitor from the circuit once the motor reaches its operating speed. This improves the efficiency of the motor. And reliability. The centrifugal switch ensures that auxiliary winding and capacitor are only used during the start of phase of the motor. This reduces the risk of damage to these components.
How does the contactor work? Well, the contactor consists of a set of stationary contacts and a set of movable contacts, which are held apart by a spring when the contactor is not energized. The stationary contacts are connected to the power supply, while the movable contacts are connected to the load. When the contactor is energized, the electromagnetic coil creates a magnetic field that pulls the movable contacts towards the stationary contacts, closing the circuit and allowing current to flow to the load. And how does the single-phase induction AC motor is electrically connected to the 127 VAC? Well, to connect a single-phase induction motor to 127 V AC power supply, you will need to identify the two main leads of the motor. The two main leads are typically labeled as the run winding and the start winding. The run winding is the main winding that produces the rotational force, while the start winding provides the initial torque to start the motor. The connection to the motor will depend on the type of motor and the specific application. In general, the motor will have a set of the terminals or wires for the main power supply, which is typically connected to a power cord or plug. And how does the protector motor works? Motor protector, also known as a motor overload, relay, or motor thermal overload protector, is an electrical device designed to protect an electric motor from a damage caused by overloading, overheating, and phase loss. The motor protector works by monitoring the current flowing through the motor and comparing it to preset value, which is based on the motor's rated current. If the current exceeds this value, the motor protector will trip and interrupt the power supply to the motor, thus preventing damage to the motor. The motor protector typically consists of a current sensing device, a thermal sensing element, and a relay. The current sensing device, such as the current transformer, measures the current flowing through the motor and sends a signal to the relay. The thermal sensing element, usually a bimetal strip or a thermistor, measures the temperature of the motor and sends a signal to the relay when the temperature exceeds a preset limit.
We have two diagrams, one for the power circuit and another for the control circuit. And in the power circuit, we have three principal wires, the power line, neutral, and ground. The brown one is the line with 127 volts in AC, and it is connected to the circuit breaker and the contactor. Then we have the blue wire that is neutral and is connected directly to the motor in order to close the circuit. And finally, we have the green wire used to connect the motor to ground. In the control circuit, we have the start and stop buttons. First, we need to connect the input of the start button that is a normally open contact to 24 volts in DC, and the output is connected to the input of the stop button that is a normally closed contact. The output of this is connected to the coil, and the output is connected to the ground. Here we have a video of the simulation in Cadecimal that shows what happens when we press each button. And first we need to turn on the circuit breaker and then press the start button in order for the motor to rotate. And when we press the stop button, the motor stops the movement.
Here we have the testing in Cadecimal that my classmate explained before. And in real life implementation, we have a video that explains how does it work. We turn on everything, the breaker and the contactor. And because we left the motor on before we disconnect it, we can see that it is spinning, where we can press the red button, that is the stop button, and it decreases its speed as it stops. And then we have the green button that starts again spinning our monophasic motor.
Well, for me, during this activity, I learned how to connect wires in an orderly way. Also, some rules like the one that we cannot connect directly from the normally open and normally closed contacts to the coil, and that first we need to connect it to the terminal strip, and finally the color norms for the wires of each corresponds to every function.
As we finish our practice, we have learned how to connect properly the motor's wires and differentiate between the cables colored and how to use different components such as circuit breakers, monophasic motors, and connectors. I think that each part of the process is important, but I would like to highlight the importance of connecting everything carefully and following the quality parameters in order to be able to fix any possible future mistake.
Well, in conclusion, what I've learned about this activity is how the start-stop system works for a motor. I've learned about how does a contactor and the motor protector works, and I learned how to read electrical diagrams and how to implement them in a real circuit. I also learned about the importance of the norms that must be followed in the industry, such as the colors of the wires that must have in order to be easy to identify.
Connecting a single-phase induction AC motor to a power supply is a technical engineering practice that provides several benefits. The protective motor ensures that the motor is safeguarded against overloads and short circuits, thereby enhancing the motor's reliability and longevity. The contactor is used to ignite and cease motor operation safely, minimizing wear and tear and ensuring consistent and efficient performance. Additionally, the industrial cabinet with an on and off actuator contacts facilitates efficiency and energy utilization by ensuring that the motor is only in operation when necessary. Therefore, this engineering practice is an effective and practical solution for connecting single-phase induction AC motors to power supplies in various industrial settings.
In conclusion, for me, in this practice, I learned how to read and connect a basic industrial diagram for this motor. I learned important from the norms and why there are certain colors and how to connect the words in the PLC and all the components and that's all.